All right, so we're going to do a long form video today. This is a very simple thing in Go that we're going to try to accomplish. We're going to be parsing a cluster name and a user ID um, for that cluster. And the concept of a user in Kubernetes is complicated, and I don't want to get into it. So, as far as we're concerned, all we're looking at doing is taking what looks like basically an email address, say rwxrob at dev, rwxrob at inf, at prod, whatever. And we want the option to be able to also do just dev inf prod and have it infer or prompt for the username. So we're going to be writing just one of those functions. And today, the first function we're going to be is how do we parse, how do we get these data fields from this thing? It's a relatively simple thing to do. Anybody that's done any shell or said anything is going to be like, why are you doing a whole video on this? Because some of you don't know Go very well, and this would be a time to talk about how to do that. So let's start by talking about how to set up a test and a module. We're not going to cover that right now. Just know this is in my lab. You can go back and look at this. I've already got a Go module set up. Here was a Go mod init. And so this is a module in its own subdirectory of a Git repo, which is unusual, but it's because we're doing it in the lab. I talk more about that in the lab video. But so here we have util underscore test. So the first thing is underscore test.go is the idiom used by Go to put test code in. So we have these inline tests that we can write, and we're going to use example-based tests, which in a nutshell are very simple. Example-based tests begin with example. They always have an output colon. God, I've forgotten the colon so many times I can't tell you. You can also do unordered space output, in which case each line will just be checked that it exists in any sort of order. So if you have something that's doing randomization or something, that a lot of people don't know that. People know about testing and they know about example-based testing, and they don't know that there's another option here called unordered underscore output. We're not going to use any of those, but just to know that that you have a function, you have an underscore test.go file, you have an example, whatever, and you have this. A lot of people that are getting into Go testing will see testing here. A lot of people that write Go don't even know example tests exists. I'm not going to make a huge case for it now. Just know that if you're, in my opinion, if your example-based tests also double as documentation and can be run by the end user, and they're very easy to read and understand by everybody. So a lot of people look down on them because they're not, fancy ass testing. Just consider that. Please consider it. It's so much easier. So this is a leftover test from another lab that I was doing before. And we're going to go ahead and do test-driven development by writing our tests first. So example, what are we going to call it? We have this second part is the name of the function. I'm going to call mine parse target. Okay. And we just have it's just a standard function, and I'm going to add output here, and just put something. And that is a test right there. So as far as tests go, that qualifies. In fact, I can now run the test by doing go test, and it will add it to the list. This is running, of course, all of the tests in the suite here, which include anything that begins with example or the other ones. So it's downloading the dependency, the YAML stuff for the other tests. If I just want to run the test for that, I can do -run, and I can use any valid regular expression to test it. Usually you can just write the keyword, in this case, parse target, which is scoped to this particular repo, and it will only run that test. I can do a couple other really cool things with this when doing test-based stuff. So one of the things that my favorite thing to do is to start up a new window and type test here for Tmux. So this is my test window, and then to start up ENTR. And so what does ENTR do, right? I'm gonna show you this. So VIC, I think it's GOTT. Yeah. Oh no, that's on change. I have a different one. Okay. I actually did a whole video about this. So I'm going to try to remember it offhand. But so ENTR runs whatever the program is that it's detected. So we're going to do go test-run. But it only runs one thing. So one of the ways to cheat is to put it in bash -c, since it's only going to run the one program. So we're going to do bash -c. I think that's right. I don't remember. We're going to try. So go run, and then was it parse target? Now we run that. It's like, oh, it needs a list of file names, right? So we need to send it some file names. So the easiest way to do this, if you just want to write the name of the file, you can just do 3 of these, and you can just type the file name if you want, and that will only check for the change to that one. But that's not really what we want. We want any change to any file in this directory or below. So we're going to actually do the other case of this. There's lots of ways to do this, but probably the easiest is this. So find dot and then anything with star.go. Any of the Go files change, then we want to rerun our test. So wait, did I do that right? I think I did it wrong. I think it's like this. Yeah, okay. So what is this doing? Actually, it would be really nice if it cleared the screen every time, right? So let's do that. Clear : and that's why we put \c. And now this test is running anytime anything changes. So we can go into the util test and go make a change. And we can say fmt println. It has to be standard out. And we can type something. And my test. Oops. I'm a huge fan of backticks just because they're easier to read. They're the same. They're just, and also you can use library. So there's our Go test is passing, and we can go back and we're good to go. So now it's time to start writing some tests, right? So let's go ahead and stub a function, the parse target function. Right now there is no parse target, and we're not calling it, so it doesn't matter. So, but let's go ahead and stub it. Let's do, I mean, it could be its own file, but we'll just put it in util.go anyway. It doesn't matter. So func parse target, and it's going to take, what's it going to return? Parse target. Okay, so we want to return. We want to return the username and the cluster name. So we'll put uname, seal name, and both of those are strings. This is Go, if you don't know. And we're going to pass in a very simple string. And a lot of times you'll see people will put in a string here. I like in a bit better than that's just my style. And so, by the way, please don't chat about anything once we're recording unless it's about the topic at hand. Just for now, that'd be appreciated. Thank you. We're going to write some code here, but let's first of all get this to work. This does not work as it stands. So we're going to return. Now you could, these are since these are named, I don't have to actually name them. I can just do a return. So that is actually valid code. And we just do this. Uname, these are also instantiated, by the way. So I could do uname equals user, because the names are included in the return list. Those get defined automatically by Go. So it's a cluster, and so now what we get in our parse target, and actually, I mean, if we wanted to not have to close it and open it all the time, we can put here we can put util.go, and we can open up a new one, and we can make this one. Oops, is it already 210? Damn. Util underscore test.go. Okay, so then we can open this up. All right. All right. So what's up with our test? Is our test still working? Okay, let's make this actually do it. So let's say let's see, uname, comma, seal name equals, and because we did util underscore test as our package, we have to qualify the package. So util.parseTarget, and I could use all the L completions as the omni-complete if I wanted. I don't always use that, but I could. I don't even remember a lot of times. Parse target. And then what? We'll just say blah for now, and we'll go check our test. Okay, so it's undeclared. Okay, so we got to fix it. We haven't printed it, right? So fmt, and we can actually print both of them next to each other. It does need to be print ln instead of print because it needs that line return at the end to parse it. The reflection that uses the test suite needs it. So we got user and cluster. All right. So if we wanted to make this pass, we can put user and cluster here. User cluster. And we got our pass. Okay. So, but that's obviously not what we want. If so this is the part where you could actually write several, combinations. Let's do that. So let's start with a simple one. Let's say we want rvxrob at my cluster. How about prod? All right, so that's one of the options. We could do it more generically. A user, user one. How about that? User one at prod. Now my test is going to fail. Oh, it should fail. It doesn't fail. Oh no. Okay. So that this should be user one at prod, right? So let's force it to fail. All right, now it's failing. Okay. So now, we've got stuff to implement here. Let's implement this first use case pretty quickly. So we'll go to 1, and we have these default values, but we really don't want those. Again, that value has already been predefined, so we really don't need it. And now it's time to split. And I'm going to look it up, but I wanted to remind myself a little bit. And we're going to use the switch statement here too. Okay, so we need to split this string up, right? So we need to split up in, right? So we could do an internet search. I'm going to do the kind of things you would do. How do I split a string in Golang? This is an internet search. This is not ChatGPT. I don't have that activated right now. ChatGPT would probably show you the same thing. There you go. So a couple of pages, and we've got it. Golang splitting a string using. So which split do we want? Do we want to use this one? So strings.split that resplits it on a comma. Do we want to split end functions? So like if there's more stuff in there. So do we want both of those? Let's try them. Right. Let's try the easy one first. I'm deliberately doing it this way. So let's do uname comma CL name. Well, first of all, let's see how many is this going to return, and what does it return, right? Strings.split. Well, let's try that. Let's see if we can do this. I know this is not going to work, but let's try it. Strings.split, and we want the string, so in, comma, and then we want to split on @sign. And I'm using again backticks. I'm a fan of backticks instead of double quotes. I just don't like reading double quotes. That's a personal thing. So how's our test? Well, okay. No new variables on the left side of blah. Now you can actually put this test output on the same pane. I tend to have a separate window for it because it usually can fill the whole screen. So especially when I'm doing this. So I'm just control AAing back and forth. And what do we have here? We have it's not splitting, right? It says nope. There's no new variables on the left side of blah. Assignment variable 2 variables, but string returns 1 variable. What does it return? Well, let's go look and see what it returns. So I hover over it, and I'm going to do Shift capital. God, I can't even remember K. Did I do it right? That was bad. Oh boy. All right, we're gonna have to pause the video. I don't have any of the Go tools installed because I just installed this stuff. So we're gonna have to do plug install. Yeah, I need to install my. You guys get a bonus content. You get to see me install my Vim plugins. So I did colon plugin install, and unfortunately, revive not found installing. So we're going to be sitting here for a little bit while it installs all the Go stuff. And let me talk about what that means while that's happening. So this is really separate video content, but I'm going to review it again. If you skip past this if you've already seen this in another video, because I will make another video on this. So my vimrc has the Go stuff in it. So Vim Go Go install binaries. It's supposed to do all the installation by default when it installs the plugin, but and that's what it's doing right now. The problem is that all these plug lines don't get run until you do install plug for the first time. and I did not do that because I just barely installed my dot files. So it's now in the middle of doing that, and these do take quite a long time to install. So we're getting those. It's no much longer than it would take you to set up like Goland or VS Code running Go. So that's what it's doing right now. Um, we'll talk about a lot about how to set up Vim for Go development, and when we do the 12-week series on getting started with Go for enterprise, beginning in January of next year. So it's still a long ways away, but I'll be doing a lot of programming off and on during co-working days like I'm doing today. But if you want to know why I generally don't do a lot of coding, I made a video about that. You can go watch that. So we're waiting for this stuff to install. Golang CI linter comes in. The other thing that you might want to include, since we're doing this, is Ale. Ale is going to get us the line, the core sort of gutter, notation that shows us something's wrong with a line in real time. And then you don't necessarily have to run your test. But we're still kind of waiting for all of this to finish. Some of it might be actually already enough. We might be able to go for it. You can always come back, by the way, if you accidentally error out of here, and it's not completely done doing all of its install. You can do that. It's still doing more, though. You can see some of the other ones are coming in. It's putting a bunch of binaries, and I'll show you the binaries that it's putting in. It's putting in .local/bin. It's loading up. See all these? These are all of the binaries that are used by Vimgo, either directly or indirectly, including the language server. People ask all the time, does Go have a language server? The answer is yes. It had one way before it was built into NeoVim. It had its own language server, and like in 2013, it had its own language server. So, because people wanted it. Looks like it's done. Okay, finishing done. Okay, that didn't take too long, but I mean, it's not, it did take a while. So, all right, so now let's actually restart here. The reason I did that is because I caught. See, now it has a little. Oh no, you have a problem here, right? See the little guy, the little skull and crossbones. Also, K. You see how down below it tells me what's wrong? It wasn't doing that before. Now it's telling me the exact error. I don't even have to look it up, right? But if I want to look up the syntax of split, I get my cursor on top of it, and I do Shift K, and I get something better, right? So now the Shift K is aware of the syntax. It uses GoDoc, and it shows you the doc. Pretty damn cool, right? And so now we have the split screen. We can see that S is a string, and the split is how many, and it's going to return a slice of strings. Or you can do equivalent count -1 if you want. So we just push enter, go back out of there. So that's what we're going to get. So we actually have to need to use an array here. So we can say, I don't know, we could say, what should we say? Out. We should say, how about F? It's not uncommon to use really small variable names based on the scope. So F, and it says, oh, you're not using F. Then you can say uname equals. Now this is a part that gets kind of crazy, and I'm just going to write it wrong first. So uname is already defined up in the return value, so return is F0. I mean, those of you who code already know this is going to have a problem, right? Because what happens if there isn't one? It's going to get you an index error, right? So, but let's actually write the test case for that. So where's our test? Here we go. Our thing is passing. Okay, so this is working for our one use case, right? Well, we have lots of use cases, so let's check our other use cases. So let's go back to 4, go check those out. Now you could make, and there's many ways to do this. One of the ways could be adding. So you could just yank this whole thing. So by the way, once we're now aware of Go, I can do this. I can do YAF, and that'll yank the whole entire function. And then I P, and I can paste that whole function down here. And then I can go to parse target, and now I can qualify it. I can say no user, and you want that to be lowercase, at least the first word, because that's part of the idiom. So now if we do this, and we get rid of this, we'll see that it is not what we want, and it'll give us the error that we are trying to get. It should get it anyway. Oh, well, actually, we told it that we wanted only parse target, and it's passing because it's not running our new one. Example parse target no user is not working because it's not calling. Maybe it. Oh, because it's got an @ sign in it. There we go. That's what we want. We want that big ass panic there. All right. So that's like, oh, I can't do it. I'm trying to access things that don't exist. Okay, we wanted that error. All right. So we force that error. Now, there's like a design consideration here. Do we want to have a bunch of independent, tiny little, um, things, or do we want to pass a whole bunch of different possibilities? Right. That's really up to you. I tend to like having, even though it's redundant, I like having redundant examples so that they show up independently in the documentation. But you could put a loop here and then just loop through all the values, right? That's also a possibility. And I mean, if I was going to do more than this, which we kind of need to do, right? So let's actually go ahead and add it right now. So YAF, we're downloading that whole function. We're copying the whole function, and we're going to come over here and we're going to do example parse target no user. Let's do no cluster, which is this is not supposed to happen, right? This is supposed to crash. So we're going to say user 1, right? Now that should that is a no cluster sort of situation. So the proper behavior there is for it to return a user 1 because it thinks that the cluster is there unless it has an @ sign, right? And then we have yet another case where we need to get actually no cluster. Let's put these both in the same test. Let's put a no cluster here. That this is also a no cluster, right? And I mean, this is kind of 2 tests in 1. I don't like it. You know why? Because it's, YAF. One thing, let's do separation concerns. I would much rather see this kind of stuff than, no cluster, but has @ that, but with @ sign. I don't know. Doesn't matter. All right, so I'll go to R2. We can see, okay, we still got that other error. Let's see if we can fix that error first. Okay, so you can actually individually, all of these are being run because they all have parse target in the name, which is good. So we want to get rid of this panic. The reason the panic is happening, if you know Go at all, you immediately know what's going on here. We are telling it that we are expecting it to have 2 fields, but we know for a fact that it does not have 2 fields, right? And this gets kind of interesting because if we could use split n here, right? And until we want 2 fields, let's see what happens there. Does that fix it? Probably not. No, does not fix it. Error index out of range. So if it has less than 2, it's still going to be a problem, right? Split n isolates it down. I'm kind of getting ahead of myself, but that's going to get rid of a problem we haven't hit yet. So we actually need to do a test here, right? So we have to say if, and this is where the switch kind of comes in. So if the length of f is greater than 0, actually, if it's 0, what do we want to do? Do we want to have an error? Or do we want to just return empty values? Probably want to return empty values, right? So we could do this. If the length of value of f is 0, go ahead and bail and return, just return, right? So let's make a test case for that. What is the test case for that? You can say no user. You can say, okay, YAF. We could say empty parse target, nothing. Parse target, nothing at all. Then what? Right? what would that be? Actually, how can we fix our test so it just tests this one? We go to our 3.8. We do it. Let's like it's doing a bunch of tests all at once. All right, let's change our test case. Let's say we only want parse target nothing. Remember, I have to change this back. I always forget. Parse target underscore nothing. All right, so still not working. So let's figure that out. Parse target nothing. Parse target blah blah blah. So that's blowing up, right? One parse target if the length of these zeros return. Oh, sorry. The length of in. Yeah. Actually, you know what we can do? We can put this first, right? We can put that first because that's like, we want to error out really quickly on that one. So I go to 2 here, got nothing, user 1. Okay, so it should have got, it says it wanted user 1. That's because our test is still wrong. So in this case, we want it to be empty. And that will be a successful test, strangely enough. So there we go. We're passing. Let's actually break something else. So do we have a specific one we want to break? Let's see. What's next? So we have no thing. What if we just have, so everything else is it has at least one character, right? If we have anything at all, we're going to assume it's a cluster, right? That's what we're kind of doing. We're assuming it's a cluster. It's either it has added the front or it's just the cluster name. If it's by itself, it's a cluster name, right? Because we're going to infer the user. We're going to infer the user. We're going to make user. We could, if it's by itself, we want it to be a user. No, if it's by itself, we want it to be a cluster, right? Okay, let's just run them all again. All right, so where are we? Actually, we got too many things crashing. So this is actually something I always do. I'm going to comment out the test code rather than isolate the test, and we'll come back to it. These ones are all working. So let's isolate the test. There we go. So everything's working. Now let's like expose our test cases one at a time. So if we just have one thing, then we want just cluster, right? So we should say no user. We should say just cluster, and that should be prod. And we know this is going to fail, right? So let's do that. So what does this code look like now? It's getting a little bit ugly. I'll add the get right spaces out. So we have the split. So now what? So now we can say if the length of f is greater than 0, then what? The length is greater than 0, then we have this going on. I got a message I got to go answer. So uname equals f0, and this one equals f1, right? That should cover us, except for this one here, right? So we actually have kind of a sub case. If the length of f, which we could actually do this, we could say FL or LF, length of f if you want. It's not that expensive to look it up because it gets inlined by the compiler, but if you wanted to, you can do that. So you can do LF. So if LF is greater than 0, there's actually a better way to do this, which I'll show you in a bit. LF is greater than 1. Then that means we've got enough stuff to do, and that's pretty intuitive just by looking at it. Let's check our test. Okay, our test passed, right? Okay, so this is pretty ugly though. So let's introduce you to the switch statement where you don't have to write length of f one time. And this is what we're going to do now. So switch length of f, and we're going to put a block here. And we don't need this anymore. And now we can say case is 0. Case the length is 0, do this. Case the length is 1, do this. Case 2, do this. And default, do this. Then is, there's a couple of weird cases there. This is my particular favorite way to do this. Um, so if it's 0, so if for some reason we tried to split and we didn't get anything, the cool thing about this is it actually takes care of this other case. So we could actually just do return here. I just think it makes the code a lot easier to read. And then case 1, if there's only one thing, then we have CL name equals F0. If there's 2, then we have the U name equals F0 and the CL name equals F1. And if it has more than that, that's actually an error. So we have to decide what to do with that. And the way to fix that is to get rid of the default, actually, and to say you should never have more than 2 things. And the way to do that is to use split n instead. Split n is guaranteed, and this actually is going to fix a bug that we might have. And this is one of those edge cases that you would not realize. So let's actually create a test case for the mistake because I know about it. So here we go. So we have just the cluster and our test is working. We could have YAF, grab this function again, make another copy. Let's say, we have the username already. That one worked. We need a just user, but let's say cluster with, this is a very edge case, right? With @. Now, I don't know why, but what happens if you have a cluster that's got an @ in it? Prod at location, right? What do you get? Now, this is a mess. This is a weird one, right? In fact, I kind of think that the use of assuming that you have that the @ is a thing, it assumes that you can't have @ in your name. But strictly speaking, this is a case where you would do it. So user 1 @ this is a very edgy case, but what would this be, right? You would get the wrong name. So let's say somebody actually does this kind of thing. You'd see it wanted prod and it got the wrong thing, right? What it really should be, the output here should really be prod at location. And that's not going to work, right? Why? Because it's not parsing it right. It's like, first of all, we're only parsing 2 things. Well, there's another case here, right? There's a default here, and we can just do println. Actually, let's do log. If I do log all the time, log.println made it, and we can print all of F here, and that'll actually log. Let's go to 2. Now, if you get there, see it says made it. So we have user 1, prod, and location. That's how you can do some debugging, by the way. Turn the logger on. And you can see that it's overly parsing. It's overly zealous, right? So this is a kind of thing that would be mixed, but this is going to be fixed by sprint end. So I don't know how sticklery you want to be about it, but that actually fixes the problem more or less, right? Because it's it's parsing the right thing. It's actually not getting to made it anymore because it's still 2. It's just parsed 2 things, and it put all of the rest into the one, and that's it. We're done. So we can go to 4. We can come over here. We can say user 1, and then prod at location, and all of our tests should pass. Okay, so that is a pretty basic thing in Go to do. That is all the code you need to do a basic parsing. Any language will have being able to split a thing is a pretty basic thing. But I figured I'd go ahead and cover it. Why not assert? Why do you use FMT print? We covered that already. Assert is not a thing in Go. We're using example-based testing, and we're not using any of the third-party libraries, which are completely unnecessary for this kind of thing. So that's why. There's there is no assert in Go. There is stuff you can do with the test with the there's two ways to do testing. You can use the testing package, or you can use the example. You can use the example-based testing that's built in and it uses reflection. The advantage of this is that you get automatic documentation for your stuff. So let me give you a sense of that. Go doc. Well, this one you don't get to see. You can see runnable examples if you use example-based testing. So that gives you something to go search for if you want to search for that. So that's what you would be looking for. The difference between uname equals x, uname equals, and uname equals CLName equals x. But you can't tell the difference between uname equals x. Right. This particular case has a kind of a flaw with the base assumption, which is that if there is only one thing, you don't know whether it's if there's only one thing, then it's automatically assumed to be a cluster name, and the username is blank. So so actually, let's do that. Let's document it, right? So parse target parses an input string containing the cluster name and optional user for that cluster separated by an @. And there we go. If let's see, if that's it. So yeah, I mean, if you put an @ in your cluster, there is a case. Note that clusters are generally assumed to not have @ in their names. But if they do, the username is required to parse them correctly. So that's it. Not the best of all, but how you doing, Mikecore? So yeah, so that's it. This is a case where the use case for this is klogin space prod, klogin space user @prod, and that is it. So there is no additional requirement to have that. Now if we said user @ then and we wanted to use the default cluster, so the default is the cluster must always be provided, right? The cluster name is always required. And just in case you're wondering, by the way, did you see what I just did there? So Go PLS has built-in support for comment formatting. So if you're on here, you can do GW and then up bracket or whatever, left bracket to do that thing. So you can get your stuff to look really good and pretty and stuff. And you see GoDoc now, it'll show you the GoDoc for this particular thing. Parse target. So you can do GoDoc -al all. Will give you the documentation gets built in automatically. That's all on that one. I got to go do some other stuff, but if you have any other questions about that, let me know. If you want to put any comments in the stuff below, please let the comments in the YouTube. There's always debate about how to do it better, but I just wanted to give people a very easy idea. Before we leave though, let's actually uncomment these other edge use cases. So this is really important that people see. Let's see. No cluster. So let's see. No cluster interprets takes assumes user is cluster. And the cool thing about this is that would go straight in the documentation example, so they would see it and they would know and they would say, that's not right, that's weird. but we want that, right? We want them to see that that's part of our business logic. Our business logic is deliberately kind of, I deliberately made an example where I put the username, and it's like it's going to try to find a cluster name user, right? Um, and actually, we could say, you could even, do a printf here. Actually, don't even need that really. We can still do println and then do user, um, and then cluster. Whoops, you can do cluster here. So, and there we go. User cluster. Yeah, that's kind of a problem, huh? I mean, or we could do printf here. Let's do printf. That's better. Yeah, you know why? Because we can actually do quote. So yeah, let's do Q here. Cluster Q. Q is an automatic quoting that's built in. When you do printf, you got to put an N though, which means you got to use double quotes instead of single. Then we can do the standard stuff. Seal name. And there you go. Now you can see that that's actually very specific. I'm going to go cut and paste this out of there and put this in my test. So now my test will pass and we're good. So now our last test, what if the user puts an @ sign? This is an absolute fail. This should not work. But I don't know how we should fail this situation. Let's actually see how it's failing right now. It's passing. Right now it's saying that user 1 and that there is no cluster name. The cluster name is actually empty. So this is actually a valid use case. So we're going to be very explicit here and print this out, and the answer should be, and by the way, you see how much easier it is to write the test? If I was doing all of this by asserting values and everything, it would be so much harder than to just test the output. So again, user-based testing is so much better in my opinion. You see here it's user 1, so we can go in here and can say user 1 with no cluster name. So this is a very, again, it's super easy to read the test. I'm going to say this again. Use example-based testing first. Default to user-based testing because you get simplified testing that's easy to read, that just uses standard out, just like if you were writing print statements, because you are writing print statements. You get stuff that automatically gets documented in all your documentation. So you tend to write tests that are human readable and understandable instead of these really complicated, obfuscated tests that are going to take 20 minutes to figure out what it's even testing. So, and 3, you get this built-in ability for other people to expand on the on your tests without having to fully understand your really complicated single test case. They can just go in there and they can modify the one you have, change the expected criteria in the output, and boom, they're good to go. So it's actually easier to expand and add new use cases by other testers. Lots of strong reasons to use that. So here we go. So now we pass again, and we've got multiple test cases, and they're all covered here, and they're all included in the documentation, which you can go look up on go.dev or whatever. The examples do not show up in the command line based documentation, obviously, but they do. I don't think they do. I don't know. Go doc dash all. Yeah, they don't. Does Go doc have something I don't know? Let's go check. I don't think there's a way to print out the tests. Yeah, we've been doing coding. So command short one-line representation, source, unexported symbols. No, show all documentation, symbol matching, changes. Yeah, it doesn't show that. So, one other thing I wanted to show you. So while we're doing, you remember when we wrote our documentation on the utility, you see how this document is here? This documentation is here. When we are in our test code over here, whoops. There he goes. When we're in here, we can actually test our documentation in here with, yeah, you guessed it, capital K, and it will pull in our documentation in real time, and it will show all of that. So there you go. You see, we got parses input and stuff, and it tells you the exact documentation. So that came, so you get all that for free, right? You can also look up the actual source code that was used with God, which one is it? I can't remember. I can't. My commands are. I can't remember it. Which is the one that looks? It's been a while. I'm kind of embarrassed. Um, I can't remember it right now. Is it control? Is it control O? Which one is it? Control L or control O? Gosh dang it, I can't remember. What's the one that looks up the source code? It's been a long time since I coded Go. I've been coding Go, the API stuff a lot, and I haven't been doing this. I need to figure out how to do it. I'm like totally spacing on it, but you have to know this. It's like really important. So control capital. I can't believe my fingers don't remember it. It's because I'm doing a video, of course. What's the one that looks up the source code and jumps around? Go to definition in Vim. Yeah, what is it? What is it? I can't remember it. Is it I think it's is it is it it's not I don't think it's GH. No, I don't think that's it. Is that it? No. No, it's something else. It's something else. I it's and it's O or something. I don't think it's all plus G, no. Oh, that's it. Oh no, that's not it. I can't believe I can't remember it. I'm so embarrassed. Yeah, well, just goes to show you. I've been using. I don't use this very much, but this is how you bounce around between, and it's N and P and O, and is it 0? Yeah, is it control that bracket? No, it's not. Oh, that's it. Yeah, that's it. I was doing the left bracket instead of the right. Yeah, and J. That's the one. Yeah, thank you. Yeah. Yeah, that's definitely it. It's actually no. What's the one that goes back now? It's like, is it O? Yeah, it's O. Okay. All right, all right. Now you know. So I can never remember that one. So I was pretty damn close. It's control. It's a Vim thing. I don't use Alt for that ever. No. Um. Yeah. GD is the other option. Yeah. I don't think GD does it. Oh, GD does it. I don't use GD. I like GD. But how do I go back? So I have mine set to P, no, to O. O goes to back. Control O for me goes back. Control O is the one that will back. It'll go back in your list, like while you're doing it. It'll continue to go back to your last thing. GD, that's easier to type. I like GD. I haven't used that a lot, so thank you for telling me about that. So yeah, again, yeah. All right, so here we are. Now you're just gonna quit the whole thing. Anyway, so if you're on here and you want to jump to where that code was written, I have control right bracket that goes there, and I totally forgot about that. And now I'm probably going to use GD. And if you want to go back though, that's the part I always forget. It's control. Is it control O or is it P? It's O. Control O. So control P goes there and control O goes back. I don't know if I even like those options now that I know about GD. Those of you who are Vim pros, even more than me, are going to be like, oh my God. Control O basically remembers the last buffer you had open, no matter what buffer it was, and it goes back to it. So these are Vimisms that I have not really been using my whole life. That's why they're so hard for me to remember. Anyway, now you know how to do it. So you can do Shift K to look up what's going on there, and you can do Control right bracket to go to its source. You can do Control O to go back, or you can do, now they just learned, GD to go to it, and then Control O to go back, and stuff. So that's all stuff you can do. That's the end of that video. Leave a comment there.